Welcome to College Algebra. My name is Gregory Carlson. We're on section 6.2, which is all about ellipses, and luckily they are a little easier, I think, to deal with than parabolas, even though the equation looks worse. Here's the equation right here. X minus h squared over a squared plus y minus k squared over b squared equals 1. All right, so let's kind of break this down a little bit. First of all, remember what an ellipse is. An ellipse is kind of like an oval. It's a circle that's been stretched kind of in one way or the other. How do you recognize that something is an ellipse? Well, first off, notice that it's equal to 1. This is what we want. We want this equation to be equal to 1, or we have some work we have to do on it. Here's another thing to notice. X is squared and y is squared. Remember that with a parabola, only x or y was being squared. Now they're both being squared. Finally, this plus is critical, this plus right here. A hyperbola in 6.3, a hyperbola has the exact same equation except this is a minus instead of a plus. And so this plus here is critical. So it's x minus h squared over something squared plus y minus k squared over something squared equals 1. Okay? Now, believe it or not, these are actually fairly easy to graph. The h and k, if you flip those two, that's the center of the ellipse. And the a and the b tells you how long the major axis and the minor axis are. So for example, if the number that's with x is bigger, then that means the ellipse is wide to the left and the right. It goes long this way. Okay? This is if a squared is bigger than b squared, or whichever value is with the x. If the other value is bigger, if b is bigger with the y, then that means it's narrow up and down, kind of like that kind of ellipse. Okay? So we'll look at some examples and you'll understand it. Notice that if a and b are the same number, then it's actually a circle, because you could multiply this number, like it's a squared and a squared, multiply it over, and that you should notice that if you had a squared over here, that's the formula for a circle, where that's the radius squared. Okay? So, and so that's basically all there is to this. So let's look at a few examples, and I think you'll discover this is not so bad. So here's the first equation. Determine the intercepts for the equation. In other words, where do we hit the x-axis and where do we hit the y-axis? Well, the thing to do is to plug in 0 for x and solve for y, or plug in 0 for y and solve for x. That would tell you all four intercepts. But this is a little easier because I recognize it's an ellipse. How do I know this is an ellipse? X is being squared, y is being squared, and we have a plus. Those are the three things we need to have an ellipse. Now notice we're not equal to 1. So we need to divide everything by 784 so that we can get this equal to 1. So I'm just going to divide everything by 784. So on the right side, I just get 1. Now, let's do 784 divided by 16. Let's flip it. And here's why. Notice it'll simplify to 49. On these easier examples, this is going to work out to be a nice number. So 16 divided by 784, like you can cancel 16 and 784 and get 49 on the bottom, okay? And again, if we do 784 divided by 49, you're going to get 16. So that was lucky. That won't always happen. So again, 49 goes into 784 16 times. So all I did there was reduce the fraction. So you notice that this is the equation of an ellipse. X squared over 16 plus y squared over 49 equals 1. Notice that we don't have any h or k here. X and y are both by themselves, which means that the center of our ellipse is going to be the origin. Okay, so the center is going to be the origin. So let's actually graph this thing really fast. You take the square roots of these two numbers. So the square root of 16 is 4. So it's going to be over 4 to the left and right, because x is left and right from the origin. Y, it's going to be up 7, down 7. And so notice that this is the major axis because it's longer, and this is the minor axis because it's shorter. How did I know it was 7? You just take the square root of 49. So connect these dots in kind of a elliptical circular orbit, and you have your ellipse. Easy as that. So if it's the plus, they're both being squared, equals 1. Left and right is the square root of the x number. Up and down is the square root of the y number. So let's actually write out the intercepts, which is what the question was asking for. The intercepts would be 4, 0, negative 4, 0. There's our first two intercepts. And the next one would be 0, 7, and 0, negative 7. So that's the best way to do this problem. You also could have plugged in 0 for x and 0 for y and solved, and you would have gotten the same results. Let's try this one over here. X squared plus y squared over 4 equals 1. Again, you need to recognize that that's an ellipse because we have x squared, y squared, and a plus sign. This one already equals 1. So what do we do about the x squared? How would we graph this? Well, remember, this is the same as x squared over 1. And 1 is the same thing as 1 squared. So hopefully you can just mentally put that in. Let's graph it really quick. And then it'll be easy to see the intercepts. So the number associated with x is left and right. So this is the square root of 1, which is 1, over left and right 1. The square root of 4 is 2. So we go up 2, down 2, and there's your ellipse. And you can see that if we have an h and a k, it just moves it up and down, left or right, and that's it. So it's really not too bad. So the intercepts are going to be 1, 0 for x, negative 1, 0, 0, 2, 0, negative 2. And that's it. So those are the 4 intercepts, and that's how to graph it. I think we have time for 2 more, so let's do these next 2. Remember, it's the square roots of these numbers. That's the most common thing that people forget. It's the square root of these two numbers that give us the values for the minor and the major axis. All right, here comes the next example. It is x squared over 25 plus y squared over 9 equals 1. Let's see what the intercepts are. Notice we equals 1, so we don't have to do anything. So it's going to be, this is square root of that is 5. The square root of 9 is 3, so it's going to be over 5, up 3, down 3. And there's our happy little ellipse, just like that. And so this distance was 5, the up and down distance was 3, so the intercepts are positive and negative 5, 0, or 0, positive, negative 3, if you want to write them. Remember, that represents 4 points total, 2 here and 2 here. Or you can write all 4 of them out like I did in the previous one. So notice the difference between this problem and this problem. It doesn't look like much, but this is actually a big difference because in here, the number that's associated with x is 9, whereas here it was the 25, which was with x. And so what do you think is going to happen to this graph? Can you imagine what's going to happen? Let's see. Now it's only over to the left and to the right 3, and it's up and down 5. So you can see that instead of opening this way, it's kind of opening more up and down. So here the major axis was this axis, but here the major axis is this axis, the one that's going, the longer one, the one that's going up and down. So here the intercepts kind of flip from here. X is positive and negative 3, y is positive negative 5. Sometimes in the homework they'll try to trick you by putting y squared first instead of x squared. So just remember you may either want to rewrite it with x coming first or just notice which number is going with x and which one is going with y. All right, in part 2 we will graph a few of these and they're not too difficult, but we'll go through them and hopefully you'll understand them after a few examples. So I will see you in part 2.